first off, these are our exponential functions, okay, like we did on our candy lab. F of x is going to equal ab to the x power. Notice that x is in the exponent, so the variable is in the exponent. That's how you know it's exponential. If the variable were anywhere else, it would not be exponential. It could be a square root or linear or one of our polynomials, but the x is in the exponent. That's what makes it exponential. Okay? We have two situations that can happen with our exponential. We can have growth or we can have decay. And by looking at the graphs, it's very easy to tell which one is growth. Growth is obviously growing up. Decay is obviously coming down and decreasing. Okay? So those are our two situations. But we can always identify growth and decay in the equation itself by looking at the actual b term. The b term will always indicate growth if b is greater than 1. Anything greater than 1. Doesn't have to be 2, 3, 4, 5, 6. It can be 1.001. Anything bigger than 1 is going to be growth. Anything less than 1, but still a 0, still greater than 0, will give us decay. Now, what's another way of saying this? These are all just proper fractions, right? Now, I would challenge some of you on your own to go and try to figure out what happens with the graph if you got actually and made your b less than 0 and turned your b into a negative number. But it really takes it to a whole different function, and I don't want to muddy up the waters here, but I could challenge you to do that on your own. So let's look at these two and let's just see what happens, okay? First off, they both have something in common. What point do they both have in common? 0, 1. Okay, right here they both have 0, 1 in common. And that is a very common point that you will see. Okay? I want to see why that happens by looking at a table of values and recreating a table of values from this chart. Okay, so I'm going to look and see where this chart came from. Now, the equation is 2 to the x power. So I'm just going to pick some numbers. I'm going to pick -2, -1, 0, 1, 2. I might even actually get a -3 and a +3 up there. Okay. Of course, I'll start easy. I think everybody likes to start easy. I'm just going to start with 0. If you plug in a 0 right here, what is 2 to the 0 power?
1.
That's right. No, be careful. It's 1. I had a lot of you say it's a 1. It is a 1. Remember, any number to the 0 power is a 1. So is that a surprise at all that an exponential goes through the point 0, 1? It shouldn't be. All right? That's pretty solid right there. Now I plug in a 1. What's 2 to the first? 2. And plug in a 2. 2 to the second?
4.
It's 4. And 2 to the third? 8. Of course, is 8. And of course, I know that you guys are smart enough to keep going with a pattern there. Right? And they do have all of those points graphed. 1 gave me the 2, 2 gave me the 4, 3 gave me the 8 on my graph. So they are all graphed on there. Now, look at it backwards, though. A lot of us struggle going backwards on the graph. If I plug in a -1 right here, and I'm going to erase this in a minute, but for right now I'm going to show my work. 2 to the -1. What does that mean?
1 over 2.
It's 1 over 2 to the 1, isn't it? Which is 1 over 2. So isn't this a half? All right. Well, what would 2 to the -2 be?
1 over 4.
1 over 2 squared, which of course is 1 over 4. So that's a 1/4. Can you go ahead and guess 2 to the -3?
1/8.
1/8, etc., etc. And you can see as you go down this line here, there's my 1/2. There's my 1/4. And it gets very difficult to start squeezing all these little tiny numbers in here, doesn't it? There's my 1/8. But you can see where that comes from. Is everybody okay with that? All right. Like I said, I'm going to get rid of my work here, but I just wanted to indicate where those came from. Let's look at the other one, just to talk about it, just to make sure. Kind of the same idea. It's actually the same as this one, but backwards. I hope you recognize that. Okay, again, -3, -2, -1, 0, 1, 2, 3. Start with the easy one. If I plug in a 0, what is 1/2 to the 0 power? Of course it's 1. Any number to the 0 power is 1. And now, when I plug in a 1, what is 1/2 to the first power? It is still 1/2. And what is 1/2 to the second power? It is 1/4 because it's 1/2 times 1/2, right? So that's 1/4. And what's 1/2 to the third power? It's 1/8. Good. Well, 1/2 times 1/2 times 1/2 is 1/8. So I think you can see the pattern again. And if you'll look once again, there they are. Here's 1 is 1/2. Here's 2 is 1/4. Here's 3, giving us the 1/8, and of course it's going to get smaller and smaller and smaller. Now, what about the whole backwards part with the negatives? I'll show my work, but I'll erase it. Think about this, 1/2 to the -1. What do you do with a -1? You put it on the, I'm saying you put it on the bottom, but it's already a fraction, so don't you just flip it? So this is 2 to the first. What's 2 to the first? It's a 2. What about 1/2 to the -2? It's going to be 2 to the second, which is the 4. Now do you see why it's going up so quickly on the negative side? Because that's 2 to the third, which gives us an 8. And once again, you can see all those points. There's the 2, there's the 4, here's the 8. All right? We okay with that? All right. Here's what I want to do then. Let's talk about the domains and ranges of these and answer a very interesting question that'll come up. First off, the domains. What kind of numbers did I choose when I chose my values? You're right, I did choose easy ones. But could I have chosen harder ones?
Yeah.
Could I have chosen anything?
Yes.
So my domain is all real, right? So I think all of you are okay with the all real. It's the range part that I'm most interested about on the exponentials. Okay? What kind of y values? After I plugged in all these x's, what kind of y's did I get out?
Greater than or equal to 0.
Okay, I just heard all my y's were greater than or equal to 0. Anybody like to argue that? Okay, go ahead and let me have your argument.
Just kidding.
Okay? It's impossible for the denominators of these fractions to ever be a 0. So these will never turn into a 0. It'll be 1 over 16, 1 over 32, 1 over 64, but it never turns to 0. So this part right here has to change to just y is greater than 0, never equal to it. At least not on the parent function. Now, could it be equal to it if we took that function and shifted it up or down? Yeah, if we shifted it, then it could be, but it won't ever be on this one. Let's look at the second one, talk about domain and range. What about the domain and range here? Domain, once again, is all real numbers. And the range on this one is everything greater than 0, but it's still never going to be equal, is it? Okay? I'm going to tell you a math joke. Okay? What's the parent function of this? Y equals... That's right, it'll be 2 to the x. 2 to the x. Okay? So I need to graph y equals 2 to the x. Well, I know when I graph y equals 2 to the x, where's it going to start? No, it's going to start at 0, 1 because they go through 0, 1. And now if I plug in a 1, 2 to the first is 2, and 2 to the second is 4, and 2 to the third is 8, and you can see it quickly making an exponential graph. And if I went backwards, of course, that'd be -1 would give me a half, and then a fourth, and then an eighth, and then a 16, and you again can see quickly. You can also see why it's a pain to graph them so low, right? All right, so there's my parent function. Now talk to me about what this new function is going to do.
Translate
It is going to translate. How does it translate? 3 up. Okay, this is an up 3, right? So all I'm going to do, guys, is just take it up 3.
points all.
So I'm going to take all of these points, since I already have them, move them up 3. 1, 2, 3. Move that one up 1, 2, 3. And graph that in there. Now, of course, what I need from you, most importantly, is going to be the domain and the range. What kind of domain do you think we're looking at? That's correct. It's all real numbers. Okay, so that's pretty nice that it's all real numbers. It's the range that's going to be my new issue here. What kind of range am I dealing with?
Everything's greater than
Remember, originally was everything above 0.
Everything above, no, it's
3. Everything greater than
up.
It's up how much? 3, that's right. So if it was everything above 0 and I moved it up 3, now it's everything above 3. So all my y's are greater than 3. Now, are they equal to 3 or just greater? Just greater. Okay. Same idea on the second function.
Wait, I'm confused. What did you do?
Since I already have my parent function graphed, how does it change? Okay, this part tells me that it's up 1. And what does this tell me? That's good. It's to the right 3. So I know that was early in the semester, but you guys are doing a really good job with that now. Okay, so I'm just going to take this exact graph, move it to the right 3, and move it up 1 for each one of those points, and it should give me my new graph. And of course, I'm going to ask you domain and range. The domain for my exponential is all real numbers. We like that. And the range,
It's greater than 1 greater.
okay, it's all the numbers greater than 1. Because remember, it used to be 0. And all I did was shift it up 1, so everything shifted up 1. So even my range shifted up 1. So as I mentioned, the growth rate is always going to be plus. The decay rate is going to be minus. And what I hope that some of you recognize is, you know, how much to do this, or how to change these things. Now, I hope you recognize all percents go to decimals in math. Okay? So what we're going to do is we're going to change this. The first thing do you notice is this a growth or a decay question, the first one? Okay, it's obviously growth, right? I'm asking you about growth because it says it. Pretty straightforward, right? So what is 3% as a decimal? 0.03. Everybody agree? Okay. And to write the actual rate, I'm going to do 1 plus that. So what is 1 plus 0.03? 1.03. Easy enough, right? This one beside it, if I have 5% growth, is that growth or decay? Obviously it's growth, right? Not trying to sneak that by you there. Now, change that to a decimal. 0.05, good. And you're going to have to add that to 1. Why am I adding it to 1? Change, it is growing. What is 1 as a percent? 100%. So 1 is 100%, right? So basically, what this says here, and I'll go ahead and finish this up, 1.05. Basically, 1.05 is the same thing as saying 105%, right? This is like 105%. Now, it's backwards for decay, though. Okay? Not really backwards, but you have to subtract. Obviously, I'm not trying to trick anybody. The questions now say decay, right? So if I'm going to decay, Everything changes.
1 minus 0.02.
And how do they change? How do you change 2%?
0.02.
Okay, that's 0.02. And I'm going to do 1 subtract that. Okay?
Oh, point.
0.8.
Oh, be careful. It's 0.98. It's 0.98. Okay? And it's really important to know the difference between a percentage and what the corresponding decay rate is. Okay? When we communicate in word problems and in real life with a boss, the boss is going to tell us, hey, something has decayed by 2%. Maybe it's the number of complaints has gone down by 2%. Maybe it's your pay raise is going to go down by 2%. Okay? But whatever it is, he's going to communicate in percentages, and we're going to have to translate that into a decimal rate. Okay? Do you recognize that 98 is kind of like 98%? So where did the 98% come from with the 2? Do you see the relationship? 100% minus 2% is 98%, right? So that's another way you can think about it. All right. So let's see. We got another decay issue on this 25 over here. So how do you write 25% as a decimal? Of course, that's 0.25, and you're going to do 1 minus that to get what? 0.75. So this is the decay rate, okay? The percentage is 25% decay, but the rate that we're going to use, the factor, is 0.75. Now, where do those come into play? I want you to look at these bottom 4 equations. These bottom 4 equations are all equations that are exponential equations. Look. I'll erase this, but it's a, b to the x. A, b to the x. Does everybody see that? Okay. So, what we want to do is we want to actually talk about the b. Now, first thing I need you to do is identify which ones are decay and which ones are growth. Okay, go ahead and help me out with that, please.
Alright, so that first one with the 200, yeah, that's a growth.
Okay. Growth, because it's more than 1. What else?
The second
One besides growth.
Both of these are growth because they're both more than 1.
Bottom 2 are decay.
And that's correct. The bottom 2 are decay because they're both less than 1. Okay? Easy enough to recognize, I hope, right? So now what I want you to do is I want you to be able to tell me what rate is this 1.35 trying to represent? 35% what? Growth. Very good. What about over here on this second one? 0.25% growth. I hope you're not afraid to have a decimal and a percentage at the same time. Okay? These tend to be the harder ones. You told me that 0.89 was decay, but how much decay is it? That's right, it's 11% decay. And I hope you can recognize the relationship between 11% and what used to be 89%, right? Okay. What about over here? That's a little trickier. No. Remember, think about this. 1 minus something gave you that, right? Do you want to change them? Sometimes. Good. So if we go ahead and change this to a percentage because you're used to seeing that, if it's 4.5% now, then it used to be 100 minus 4.5%. It used to be 95.5% decay. All right, and in context, do I have growth or decay on this first one? A population of 5,000 is increasing. Okay, clearly that's growth. And we didn't talk about this, but when you see these words right here, percent per something, for example, percent per year, or percent per day, or percent per hour, then that is almost always an exponential equation. Okay? So that key word, percent per year, is telling us that we're in exponential land right now. Okay? You told me it was growth. How much growth? What is 2.1%? 0.021. But what number would represent that? 1 plus that. It's going to be 1.021. So this is my growth rate, right? How close are we to writing an equation? We're actually really close. We're actually really close because guess what? Isn't this y equals ab to the x? And you just told me b. So the only thing I'm missing is my x. And what's the a? The a is 5,000. So that's good. You just wrote an equation. And now you can use that equation to solve. Let's keep that in mind. Let's do a population that decreases. If it's decreasing, what's going on? Okay, it's a decay. Good. So the word decrease indicates a decay. So I need to talk about this percentage. What is 1.3%? How do I rewrite that? 0.013. And it's decaying, so I'm going to do 1 minus that. What is 1 minus 0.013? 0.987. And I'm very close to having an equation. What would my equation be? Y equals 2,500 times 0.987 to the x power. Some of you aren't sure about the 2,500. That's your start. Okay, that's your initial value. All right, it looks good, guys. Just help me out with these last two real quick. Okay, this 4.5%, is this growth or decay? Okay, it is growth. All right, and some of you can go ahead and skip to the fact that this is 1.045. Right? So my equation would be y equals 200 times 1.045 raised to the x. Now, once again, I want to reiterate, isn't this like saying 104.5%? If I multiply myself by 100%, then nothing changes. But if I multiply myself by more than 100, then I'm growing. And that's what this does. And my truck. I do. My truck depreciates at a value of 5.1%. So how much is it decaying? Okay, that's 0.051, which is what number? 0.949. That's right. What equation could I use? 21,000 times 0.949 to the x power. And like I mentioned on the percentage, if my truck is going down, then it is losing value. It is less than 100%, right? What is this? This is about 94.9%. Okay, so it is less than 100%.